Hi everyone, I'm Prachi Sahu, co-presenting with Nitin Nizhawan. We both work at Microsoft and our topic is optimizing SNAT ports and IP address management. So I'll start with what is SNAT. SNAT is basically a very core networking concept used when a private cluster wants to do egress communication to a public endpoint. Here, the private cluster will obviously have private IPs, so this needs to be translated to source public IPs. This translation is called source network address translation. Now this snatting is provided by two solutions, standard load balancer and egress gateway. We use standard load balancer because it's faster and cheaper. But if it's faster and cheaper, then what is the catch? The catch is standard load balancer allocates SNAT ports statically. Meaning if you see on the right-hand side, each node will have a static number of SNAT ports, which is 4096 in this case. So if we make the SNAT ports constant, this is the formula you see as point number 1 to calculate number of IPs in the cluster. So when we multiply SNAT ports per node into number of nodes in the cluster, we get total number of SNAT ports in the cluster. And since each IP provides 64,000 ports, when we divide by 64,000, we get total number of IPs needed in the cluster. So here we see that number of IPs are directly proportional to number of nodes in the cluster. This means as the cluster auto scales, the number of IPs required increases. And that's what exactly we want to solve here, because IPs are a constrained resource in a region. And this is what our main challenge is. Now let's see what AKS does to its Kubernetes cluster. What AKS does, while calculating these IP addresses, the required number of IPs needed in a cluster, it uses max pool size of the cluster. So if you see the example on right-hand side, we have 3 node pool types in the cluster and each have max size of 250 nodes. In total, 750 max node pool size of the cluster. When we use 750 and 4096 SNAT ports, we get 48 IPs to be attached to the cluster in order to support 4096 SNAT ports. So this is the story what AKS does. But in reality, if you see the same example, the actual number of nodes in the cluster are just 50 per node pool. That means in total, 150 nodes actually are running in the cluster. That means when we use 150 as the number with the same formula, we get almost 10 IPs. That means 48 IPs are actually attached to the cluster, but we are just using 10 IPs. That means almost 80% of IPs we are wasting and not using. Maybe we can use them during the peaks, but normally the 80% of IPs are getting wasted. So this is exactly what our challenge is. We want to optimize allocating IPs dynamically so that we do not end up exhausting a constrained resource.
So to solve this problem, we want to allocate IPs based on the actual number of nodes. But AKS does not allow this normally because it has a validation where it makes sure that there are enough IPs available based on the max number of max node pool size calculation. So we disable that validation. But after that, when we allocate IPs as per the node in the cluster, now autoscaler cannot add more nodes to the cluster and cluster cannot scale up because when it tries to add more nodes to the cluster, there aren't more IPs there. So to solve this, we keep a margin of around 50 nodes. This could be any number. And we allocate IPs for whatever node is there plus 50 nodes in the cluster. And we also configure autoscaler to autoscale the cluster in the batches of 50. So instead of just scaling the cluster in one go, it will do it in the batches of 50. And now because we have like IP addresses for 50 more nodes, it can add 50 nodes. And then we will see that, okay, number of nodes has increased and we can add more IPs and then it can add more nodes to the cluster. So to implement this strategy, we run an agent in the cluster which watches the node count of the cluster, and we have a CRD which tells that what is the number of SNAT ports that needs to be configured on the node. And the agent looks at this number of nodes and this CRD configuration and creates new IP address instances and attaches them to SLB using AKS control plane API whenever the number of nodes reaches a certain threshold. Now, one way to calculate this threshold is, as we discussed in the last slide, where we allocate IPs, keep a margin of 50 nodes, and autoscaler can add 50 nodes, and then we'll add IPs for 50 more nodes. But this is a very slow scale up of the cluster. So for larger cluster, we keep a margin of in terms of a percentage of current nodes. So for example, we can keep a margin of 30% of the nodes. So if we have 200 nodes in the cluster, we will keep allocate IPs for around 290 nodes in the cluster, and cluster autoscaler can scale up directly to 290, and for larger cluster, it can scale up even larger sizes. So this solves that problem. In future, we also plan to enhance this feature to release IPs addresses when the cluster scale down happens. And also right now that we have to configure the SNAT ports using CRD, but in future we can also increase the SNAT ports whenever there are SNAT port exhaustions, and IP will be added automatically using this solution to the cluster. Thank you.
Thank you.